Hello everyone. As you know, we are dealing with electrophilic substitution reactions of phenol. The very first electrophilic substitution reaction that we have to discuss is nitration. The topic is involved in 12th, JEE, NEET and B.Sc. Let's check. First, we need to understand what is the meaning of nitration. This is phenol. These two hydrogens are ortho hydrogens. Next two hydrogens are meta and this hydrogen is para. If after reaction any hydrogen is substituted by nitro group, NO2 group, but any hydrogen cannot be substituted, I have already told to you the reason behind for it. Only ortho and para hydrogens can be substituted by NO2 group. So if this ortho hydrogen is substituted by nitro group, this is known as nitration of phenol. Ortho nitrophenol is generated. This is known as nitration of phenol. Similarly, you know some particles of phenol in which hydrogen, this hydrogen, para hydrogen can be substituted by nitro group. One more product is possible there. This one, which is known as para nitrophenol. So two nitro products are possible, orthonitrophenol and para nitrophenol. This process is known as nitration. The replacement of ortho hydrogen and para hydrogen by nitro group, NO2 group. This is known as nitration. And obviously, to bring out nitration, we required chemicals, reagents. What chemical, what reagents we can use? Let's check. Two chemicals we can use. First one is the mixture of concentrated nitric acid and concentrated sulfuric acid. This mixture is also known as nitrating mixture. Second reagent that you can use is dilute nitric acid with some heat. These two reagents you can use for the nitration of phenol. Now one by one, let's check how these reagents can bring nitration of phenol. The very first, the mixture of concentrated nitric acid and concentrated sulfuric acid. Out of nitric acid and sulfuric acid is strong and nitric acid is weak. So strong acid will provide us H positive ions. You know what are acids which provide us H positive ion. What are H positive ions? They are known as hydronium ions, in which hydrogen have a vacant orbital, one electron is not there, so carrying a positive charge. These hydronium ions are working as an electrophile. They are looking for the electrons. Now who can provide electrons? The weak acid. The weak acid will work as a base here. Strong acid will provide H positive, weak acid will accept it. This is nitric acid bonding. In this fashion, atoms are bonded there. Normally nitrogen make 3 covalent bond, but here nitrogen is making 4th dative bond with this oxygen. This is dative bond, due to which it is carrying +1 charge. It has used its lone pair to make dative bond with this oxygen. That's why +1 charge is there. So this H positive ion will attack on this oxygen, due to which this oxygen will make 3rd bond with hydrogen and it will become this. Obviously 3rd bond with hydrogen will be a dative bond. Now because it is using lone pair, so one lone pair will be finished and positive charge will come. Why? Because out of these two electrons, one electron it will completely transfer toward hydrogen, like this, and one it will keep with itself. So plus one charge will come. In this condition, it will become unstable. It will break bond from nitrogen, and obviously when it will break bond from nitrogen, both electrons will be shifted toward oxygen, because right now oxygen is more electronegative as compared to nitrogen. So what will release out? H2O. Oxygen will have two pairs now. Water molecule will release out. And what about this nitrogen? Look, already it has lost one electron, so it is carrying plus one charge. When it will lose this electron of its, charge will increase. It will become plus 2. And a vacant orbital will generate over it. This is known as nitronium ion. Overall charge will be plus 1, because you can check plus 2 minus 1. If you will add them, the overall charge will be plus 1. That's why it is written like this, NO2 plus 1. It is nitronium ion. This nitronium ion will bring out nitration of phenol. When I will solve the mechanism, then I will tell you. So in this fashion, this nitrating mixture is working as a nitrating agent. It is providing us nitronium ion, and these nitronium ions will bring out nitration of phenol. Now let's check second reagent, dilute nitric acid. What dilute nitric acid is providing? Dilute nitric acid is also providing us nitronium ions. Same pattern. This is a first particle of nitric acid, and this is a second particle of nitric acid. Out of two particles, one particle will give us H positive ions, like this, and itself it will become this, because oxygen when will break bond from hydrogen, obviously electrons will shift toward oxygen. Hydrogen will release out as H positive. Now this particle, you can check what is the overall charge, plus 1 and minus 2. So overall charge will be minus 1. So NO3 minus 1, nitrate ion we call it. This H positive ion again will attack on oxygen, and this oxygen will break bond from nitrogen, like in mixture of concentrated nitric acid and concentrated sulfuric acid was happened. Same here it will happen. H2 will release out, and this part will become this. Vacant orbital will generate on nitrogen, nitronium ion. So this nitronium ion will bring out nitration of phenol. So dilute nitric acid will work like a nitrating agent in this fashion, and concentrated acid, nitric acid, and concentrated sulfuric acid I have already discussed with you. So these are the two reagents which you can use to bring out nitration of phenol. Now let's check what is the mechanism, how nitration will be done. This is phenol. So suppose we are using dilute nitric acid, and we are heating it up to 298 Kelvin temperature. We know what this dilute nitric acid will provide us. It will provide us nitronium ion. This is nitronium ion. Nitronium ion is a very strong electrophile. Vacant orbital is there on nitrogen, so it is looking for electron. Where it will get electron? Benzene ring of a phenol is a best source for the electron. And which positions? Ortho and para positions. Reasons already I have discussed with you. So here I am going to attack this nitronium electrophile on a ortho position. This one. This nitrogen wants to make bond with this carbon, but it don't have electron for the bond formation. So the responsibility of providing electron will be of this carbon. What this carbon will do, it will bring these pi electrons toward itself, and with the help of these pi electrons, it will make a dative bond with nitrogen. So the next condition generated will be this. Between this carbon and this nitrogen, dative bond will generate. During formation of dative bond, one electron will be completely transferred toward nitrogen. So its +2 charge will become +1. This electron, this one. And this electron, this carbon will keep with itself. Hydrogen as it is, and rest molecule as it is, no change. Here hydrogens are available, you can draw by yourself. Now this carbon has lost its electron. This electron was of this carbon, but now this electron is toward nitrogen. So this carbon will become positively charged carbon with a vacant orbital because it has lost its electron. A carbocation intermediate will generate. Is it a final product? No, definitely it will not be a final product because it's an intermediate, unstable it is. So what will happen next? This carbon, this one, who has created this carbocation, will finish this carbocation. How? It will break bond from its hydrogen, and obviously when bond will break, the electrons will go toward carbon because this carbon is more electronegative than this hydrogen. And what this carbon will do with this electron, it will use to make bond with this vacant orbital like this. Vacant orbital, and this pair of electron will come here and bond will generate between these two carbon. And hydrogen will release out as H positive because it has lost its electron. This electron was of this hydrogen, but this electron is going to that side for the bond formation. So this hydrogen will release out as H positive. So finally what will happen? This we will get. Bond will generate between these two carbon. Nitro group has added there. Oxygen, hydrogen as it is. And what is released out? H positive is released out from ortho position. Means this electrophile has replaced this electrophile. This is also an electrophile, no? So that's why we call it electrophilic substitution reaction. Now because this is nitro group, so we are calling this process nitration. And which position I have attacked? Ortho position. And please note down this one. After bond formation, +1 -1. So the overall charge is 0. So sometime directly we can write it like this. OH NO2 without any charge. But in actual there is a charge. +1 charge on nitrogen and -1 charge on oxygen. But they are neutralizing each other. So that's why overall charge on the nitro group is 0. So no need to write. In this fashion, you can make mechanism of para attack also. Here I have attacked ortho position. You can attack on para position and para nitrophenol will be generated. So this is the mechanism. Please note down. Now the important point, when phenol we have reacted with dilute nitric acid and we have heated it at 298 Kelvin temperature, some molecules of phenol will turns to orthonitrophenol, some molecules will turns to paranitrophenol. This is orthonitrophenol and this is paranitrophenol. As I told you, para substituted products are major product because the groups are far away from each other, there is no steric hindrance or repulsion problem. But in ortho, the groups are very close, so due to which they are feeling repulsion problem or steric hindrance problem. That's why the molecule will become unstable. So ortho substituted products are less, or you can say minor amount, and para substituted products are in large amount, major product. But here in this nitration process, exceptional behavior is there. Ortho substituted product will be major and para substituted product will be minor. Important point. Whenever we have exceptional points, they are always important in chemistry. Let me tell you the amounts. These particles will be 40%, means in product out of 100, 40 particles will be of orthonitrophenol, and only 13 particles, means 13%, are of paranitrophenol. 40 plus 13, 53. Then where is rest 47? Wait, I will tell you later. First, let's discuss this point. Why ortho is major? It should be minor. Why it is major as compared to para? This is the point. It is major due to this. Actually, what is happening? As you know, this oxygen is more electronegative than nitrogen. So what is happening? These particles, these electrons are little toward oxygen side, means this oxygen is negatively charged. And here this hydrogen is positively charged because this hydrogen is less electronegative than oxygen, so electrons are shifted toward oxygen side. That's why it is carrying positive charge. This positively charged hydrogen is attracted by this negatively charged oxygen, like this. Means that two groups are holding each other, and this force of attraction between hydrogen and oxygen is known as intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Due to this intramolecular hydrogen bonding, the groups are attracting each other. Rather than repulsion, they are attracting each other. That's why this molecule is getting stability, extra stability. Such case is not possible in para because the molecules are far away from each other. Such interaction is not possible. That's why orthonitrophenol is major as compared to para. This is exceptional behavior of orthonitrophenol. This one. Now, the next point is, where is that 47%? Out of 100 particles, 40 particles are converted to orthonitrophenol, 13 particles are converted to paranitrophenol. Then what about rest 47 particles? Next video, we will discuss it. Thank you very much for watching it.